So we're going to solve equations. There are one-step, two-step, and multi-step equations. Okay, so if you have a one-step equation, okay, these require one step to solve. So you will either add, subtract, multiply, or divide. You'll always do the opposite operation. Okay, so when we're solving equations, we're undoing what has been done. So if I have, say, for example, x plus 3 equals 10. 3 has been added to x, so to find out what x is, I want to undo the addition, so I'm going to subtract. So I'll take 3 away from both sides. And the reason I do this is because plus 3 and minus 3 cancel each other out. And then I know what x equals. And that's what I'm trying to do. I'm trying to get x alone on one side, numbers alone on the other side. If I have subtraction, I'm going to add to both sides, again, because these will cancel. And I'm left with an x. And then negative 15 plus 6 is negative 9. If I have multiplication, this indicates multiplication, right? So if I have multiplication, I'm going to divide. Again, because division undoes multiplication. So x will be 12. Actually, that's not going to be. Okay. And then this is division. Don't think of it as fractions, think of it as division. So I'm saying x divided by 6, and this is a negative, so I'm going to multiply both sides by negative 6. Because this negative will cancel that negative, and this 6 will cancel that 6. And I'll be left with x. And then negative 10 times negative 6 is 60. So basically, if they subtracted, you add. If they added, you subtract. If they multiplied, you divide. If they divided, you multiply. And by recording that, okay. So essentially 2/3 x is the same thing as saying 2 times x divided by 3. Numerators are multiplication, denominators are division. So I've got two operations happening here. So I can either multiply by the reciprocal 3/2, which cancels out the fraction, and do this in one step, or I can do it in 2 steps. I can multiply by the denominator, which undoes the division, and then I divide by the numerator, which undoes the multiplication.
Can you do the first one with a number that won't cancel?
Sure. Let's do 3/5 x equals 7. That won't cancel. So then I multiply both sides by 5/3. And these will cancel out, so I'm left with x. And what I have to do now, because 3 doesn't go into 7, I multiply the 7 times 5. And I get 35/3. Which, if I was doing a decimal, it would be 11.67, approximately. So if I use method 2, I'd multiply both sides by 5, so I get 3x equals 35. And then I would divide both sides by 3, so I would get x equals 35/3. I'd get the same answer. It's just, which do you prefer? Do you prefer this one-step situation, or do you prefer breaking it down into 2 steps? Is that easier for you? It does not matter to me. All right, so whenever you talk about translating an equation, anytime they say a number, this means a variable of some sort. You can pick any letter you want. Quotient is division, product is multiplication, negative obviously, equal is equal, is means equal. Okay, so the quotient of a number and 4 is 6. Whenever it says quotient of, and then some other stuff, that means the first thing divided by the second thing, or the first over the second. So this one, A, quotient of a number and 4, I'll just use x for a number over 4 equals 6. So quotient of a number and 4 is 6. The product of, well, product is multiplication, so the product of a number and 4 is 6. So that would be x times 4 equals 6 if you wrote it in their same exact order, but we never write it that way. We do 4x equals 6. So these are both correct, but this is standard, yeah. This is more correct. Okay, negative 12 is equal to, so negative 12 is equal to, sum is addition, so the sum of negative 5 and a number. And D is the value 1.4 subtracted from. Okay, so when they say subtracted from, it's usually something subtracted from something else, so it's the second minus the first. So this is going to be x, because it's from a number, minus 1.4 is 5.7. Okay. There are a couple times where it does that backwards thing where the second one comes first. Subtracted from is less than, not is less than, just less than. So like 5 less than a number would be the same thing. It would be x minus 5. So this one gives you the second minus the first as well. All right, so we want to solve this equation, and I have variables on both sides. I don't want variables on both sides. What I want is variable equals number. So I want all my variables on one side, all my numbers on the other, and it does not matter which side is which. I just want numbers on one side, variable on the other. So what I usually do is I'm going to move a variable by adding or subtracting it to the other one, to the other side. So I'm going to move this 2x over here with this 6x. And so my first step is going to be to subtract 2x from both sides. And the reason I'm subtracting it is because it's positive. If it was negative, I'd add it. Yeah.
I'm still trying to understand. I have to subtract 2 from both sides.
We're doing, this is technically, this is the subtraction property of equality. Basically, what you want to do is you want to think of your equation is like an old-fashioned balance scale. And anything I do to one side, I have to do to the other side. Otherwise, I'm no longer in balance. And what I like to think of is my variables are like paper bags with stuff in them, maybe blocks or marbles or coins or something. There's something in the bags, but I'm not allowed to open the bags. So here, I'll draw you what I mean. So I have a balance scale, right? And this one has, that's a terrible picture, okay. So this equation, here's my balance scale, has 6 bags on one side and 2 bags on the other. And these bags all have the same amount of coins or blocks or whatever in them. Except from this side, I have taken away 4 blocks, and from this side, I've taken away 8. That's the -8. This works better as a visual with their pluses, but we'll just do minuses for right now. And my job is to figure out, without opening the bags, how many blocks are inside each bag. So the first thing I'm going to do is I'm going to take 2 bags away from this side and 2 bags away from that side. If I take these 2 bags away and these, I have to take 2 bags away here too. Okay, so I'm going to do that. Take those away and take those away. That's this step. So I'm isolating, basically I'm isolating the bags. So I can try to get it down to 1. Okay, because I'm trying to get 1x alone. And by getting 1x alone, I'll know how much it's worth, because I'll have 1x over here and some number over here. And that tells me what the x is worth. Now again, this is a better visual when these are pluses. But, so now I have a 2-step equation. 4x minus 4 equals -8. So 4 times x minus 4 was -8. If I took 4 away from these 4 bags, in order to find out the weight values, I have to put 4 in. So I'm going to add 4 to both sides. And that tells me that 4 bags were worth -4.
Before you go on,
Uh-huh.
would it also be acceptable to say the reason why you changed the sign is simply because it crossed the equal sign?
Oh yeah, absolutely. We do that too.
So positive 2 would become a -2 simply because it crossed the equal sign?
Yeah, every time, okay, that's if you cross the equal sign, if I pick up something from here that's positive and I move it over here, it becomes negative. And if I have something over here that's negative and I move it over there, it becomes positive. It's like teams. If you're on this team, you wear this jersey. If you get traded to that team, you're not going to wear the same jersey. So if that way works better for you visually, or that works too. So I didn't write the second step. The second step was I was going to add 4 to both sides. Okay, so I've moved all my variables to one side. And now I've undone the addition or subtraction, and then I have to undo the division or multiplication. So my last step is going to be divide both sides by 4. So I divide this by 4 and I divide this by 4, so I get x equals -1. We have to decide. Some people prefer that their variables are always on the left. Some people prefer that their variables are always positive. So you have to decide, do you want your variable on the left? And so you'll subtract 7x from both sides to move this 7x to over here with the 3x and make it on the left, which will make it negative. Or are you so anti-negative that you would rather have it on the right and subtract 3x from both sides? So let's take a vote. You'd rather have it on the left. You're anti-negative, so you want it to be positive. Okay, I have 1, 2, all right, we're going to do that then. So I'm going to move my 3x to this side to keep it positive, which we can do that. We can put it to any side. It doesn't matter which side, just so long as we move it all to one side. So those go away. So I have negative 10 is equal to 4x plus 6. Now I have a variable on the right, which is usually a little bit unusual. People aren't very comfortable with that because it's not very commonly seen. So to know, do I add 10 to both sides or do I subtract 6 to from both sides? You want to get away from the x. You're trying to get everything away from the x and get the x by itself. You're trying to isolate it. So I'm going to subtract 6. So that's going to give me negative 16 is 4x. And then I divide by 4. So I get negative 4 equals x. And if you don't like that, you can always rewrite it the other way. I'm a variable on the left kind of person personally, but that's just me. It really doesn't matter. It's the same.
How about changing all the sign, the variable to one side?
We have a situation where we have parentheses. So there's some distribution first. So you always want, oh, green is a bad color. Guys, shh. You always want to do distribution first. Okay. I'm also going to add 7 and 3. Well, you know what? I'm not going to do that because you can. You can add the 7 plus 3 in the same step, but I'm not going to do that because I don't want to confuse. I'll show you the shorter version after I show you all the steps individually. So we do 2p minus 6. And then I'm going to collect like terms on each side. Okay, and these steps that I'm writing right now will work for bigger equations as well. So you do all your distribution first, then you'll collect all your like terms on each side. So I get 10 on this side is 2p minus 6. Then if I have variables on two sides, I would move one of them. Right. So I'm just going to write that as a step. Make sure all your variables are on one side, which they are. I only have p's here on this one side. And then I want to make sure my constants are on the other side. So by that I mean you're going to do your adding or your subtracting. So I've got a minus 6 here, so I'm going to add 6. So I'm going to get 16 is equal to 2p. And then I'm going to multiply or divide. And I'm saying the number attached because in this case it's a coefficient, so I could say, you know, divide by the coefficient, but then if it was like p over 2, that's not actually a coefficient because p is being divided, so but it's still attached. So here I'm going to divide both sides by 2. And I have 8 equals p. So same steps. First we're going to do any distribution. So I have some distribution here. And again, you could do this in less steps. You could combine like terms at the same time, but I'm not going to do that. Okay, so first I distributed. So 1, distribute. 2, collect like terms. And that's on each side, right? So we're not crossing the equal sign yet. So I've got a 2 and a negative 5 here. So that gives me 7x minus 3. Because 2 minus 5 is negative 3. And then on this side, I have 6x and 2x that are alike. So that gives me 8x plus 18. So far, okay? Now I decide, do I want a positive x or negative? Positive, I guess we decided we like positives. So I'm going to move x's to one side. So I'm going to subtract this 7x from both sides. 8x minus 7x is just x. Then I'm going to add or subtract. I got the 18, so I'm going to subtract that 18. And that gives me negative 21 equals x. And then step 5 would be to multiply or divide. But right now it's not necessary. So I'm just going to put if necessary there. This might not also be necessary. These are kind of all if necessary, because maybe your x's are already on one side. Maybe you don't have any like terms. Maybe there's no distribution. So it depends on your problem that you actually have. You may not have to do all 5 of these. You may only have to do 2 of these, or 1 of these, or 4 of these. Okay, so types of equations. Linear equations have one, okay, and this is not true either. It should be a linear equation in one variable. Sorry, that should go right there. A linear equation with more than one variable has more than one solution. So a linear equation in one variable has one unique solution. So these are the type of equations we're solving right now. Has one solution. An equation that is true for some values of the variable but false for other values is called a conditional equation. That seems kind of odd. If you have no solution, you're a contradiction. An equation with no solution. 4x plus 6 is equal to 4x minus 10. How can 4x plus 6 equal 4x minus 10? It can't. This would be a contradiction. And if you tried to solve this, you would take the 4x's away and you would get 6 equals negative 10. This is false. And an equation that has real numbers as its solution set is called an identity. At this point in time, you're only working with real numbers. So all of the equations that you'll be working with are identities. And real numbers, we have real numbers, and then we have imaginary numbers, which involve square roots of negatives. We're not there. We like I, he's fun, but we're not there yet. Okay, so essentially all of the ones you'll deal with right now are identities. And essentially all of the ones we're going to deal with right now are conditionals. Okay, so if all real numbers, so 4x plus 6 equals 4x plus 6, this is true, you guys agree? Because when I solve it, I get 6 equals 6. So it doesn't matter what x I put in. This is true. All of the other equations that we solve and we get x equals 4 or x equals negative 13 or any number you get is conditional. When a variable equals a single number. And contradiction is when it's false, and identity is when it's all true. Solving equations with fractions in it is yucky. So we get rid of the fractions. So first you find the common denominator. Denominator is with an n. Okay, so I have a 6, a 4, and a 3. So I'm looking for a number that 6, 4, and 3 will all go into. 12. So in this case, it's 12. Okay, so then I'm going to multiply every term by that common denominator. So I've got 5 6x minus 3/4 equals, you'll notice I'm leaving space because I'm going to multiply them all by 12. Okay. Now, why do I do that? Because a nice, beautiful thing happens. 6 goes into 12 twice, and 2 times 5 is 10. 4 goes into 12 3 times, and 3 times 3 is 9. And then 3 goes into 12 4 times, and 4 times 1 is 4. And my fractions are gone. So step 3 is yay, no more fractions.
So in other words, once you find that LCD
Mm-hmm.
thing,
Mm-hmm.
it's going to get a smooth sailing.
Pretty much smooth sailing from there. So then I'm going to do the solve as normal. All right, so I'm going to add 9 to both sides. And I get 10x equals 13. And then I'm going to divide both sides by 10. And hey, 13 does not divide by 10, but that's okay. Because 13/10 is just fine. Now, if I had solved this with the fraction, I would have had to take the common denominators and make all of these have common denominators and then do the addition and the subtraction and all that stuff. It's much nicer by just finding the common denominator and using that to get rid of the fractions. Because you have to find the common denominator anyway. You might as well do it to get rid of the fractions rather than to do all that other mess. We're going to do the same process. We need to find that common denominator. So I've got a 3 and a 2. So my common denominator is 6. My LCD, least common denominator. Okay, so this is where it gets a little different. I'm going to multiply each term, like I said, but I don't multiply inside the parentheses by 6. It's only outside the parentheses. Okay, because 1/3 is already it's already 1/3 times x plus 7. So if I multiply 6 times 1/3 and then 6 times x and then 6 times 7, I'm actually multiplying by 6 twice. And I only want to multiply by 6 once. Does that make sense? So you only multiply this outside the parenthesis by the denominator, not inside. So 6 goes into 3 twice, and 2 times 1 is 2. And 2 goes into 6 3 times, and 3 times 1 is 3. And that's so much prettier. Then I'll distribute. And then I'm just going to write solve as normal. Because we already wrote down the steps for this. So 2 times x, 2 times 7. Don't forget to multiply everything by -3, not just 3. So I get 2x plus 14, negative 3, so negative 3x minus 3 equals 24. 2x minus 3x is negative x, right? So 2x minus 3x. And 14 minus 3 is 11. Then I subtract 11 from both sides, and I get negative x equals 13. I don't want negative x. So what I do is change both signs. So if negative x equals 13, x equals negative 13. Essentially, what I did is I divided both sides by negative 1, or multiplied both sides by negative 1. Yeah, because there's like an invisible 1 there. But if you just change both signs, you're good. So if they're both negative, you make them both positive. If this is negative and this is positive, it's now positive and negative. And if they're both positive, you leave them alone. Don't want to, you can clear fractions, you can also clear decimals. We want to count the largest number of decimal places. Okay, so I'm going to go in here and I'm going to go, okay, this has 1 decimal place, and this has 2 decimal places. 2 is my largest number of decimal places. So in that case, it's 2. Then I'm going to multiply each term by that power of 10. Okay, and so if it has 1 decimal place, I multiply by 10. If it has 2 decimal places, I multiply by 100. If it has 3 decimal places, I multiply by 1,000, etc. So since I had 2 decimal places, I'm going to multiply everything by 100. So 2 decimal places, so 100 times everything. And what that does is it moves my decimal places 2 over. So this 0.2 times 100 is going to come over twice, and it's going to become a 20. This 0.45 times 100 is going to move my decimal 2 places, and so it's going to become a 45. And this 12 times 100 is going to move my decimal 2 places, so it's going to become 1200. So this is now 20 times x plus 4 minus 45 times x plus 9 is equal to 1200. So now you're dealing with some rather large numbers, but no decimals. So it's a preference. Then I'll distribute. And I'm just going to say etc. because we've already got the steps for the rest. So I'm going to multiply 20 times and 45, negative 45, don't forget the negative. So that gives me 20x plus 80 minus 45x minus, anybody have your 45s memorized? No? Okay. So minus 405 is equal to 1200. 20x minus 45x is negative 25x. And 80 minus 405, well, is negative 325 is equal to 1200. So I'm going to add 325 to both sides. and I get negative 25x is equal to 1525. And I'll divide both sides by negative 25. And I will get x is equal to, let's see, 5, 1, 2, 6, 65. Yes, 65. That's what I meant. I was just checking to see if you guys were paying attention. Okay, so 61. Now, if you had left the,
So like negative 60.
yes, negative 61, thank you. If you had left the decimals in, basically all of these numbers would have been exactly the same, except 2 decimal places over. So I would have had 0.2, 0.8, 0.45, 4.05, 12. 0.25, 3.25, 12, 0.25, 15.25. I mean, you would have gotten all the same numbers, and except with 2 decimal places over until here. This would have still been 61. So if you don't mind working with the decimals, you can.
Also, we say, in other words, you have to go to the step that involve
They're